Okay, great. So once again, welcome everyone, and welcome to New Lives for Lithium-ion Batteries, Exploring E-Waste, Electric Mobility and Energy Nexus webinar, and also Happy International E-Waste Day, which is celebrated today on the 14th of October. So UN Habitat, the Urban Electric Mobility Initiative, known also as the UEMI, Solution Plus Program, Urban Pathway Program, and Wuppertal Institute came together today to organize this webinar to celebrate the International E-Waste Day, and also to officially launch 4 factsheets paper on lithium-ion batteries. These 4 factsheets papers deal with the initial design, repurposing, refurbishing, and recycling of these batteries, and identify and explore the synergies between e-waste, mobility, and energy. These like looking at the second, third lives of this type of batteries is quite a new topic that it's coming on the scene now. And while it is promising and it gives us opportunities to explore new business models to move towards circular economy, it also has some challenges that we should address by increasing the dialogue and exchange among the different actors and segments of the value chain. And that's why also we are also here today to bring together different partners and understand how these batteries can have several lives and increase the sustainability of batteries and our lives in general. So I give now the word to Oliver La, who will give us the opening remarks. Oliver is the coordinator at the UEMI, which is a platform funded by UN Habitat, and is also the coordinator of a Solution Plus program, a program funded by the European Union. So now,
thanks a lot, Francesca, and
welcome.
Just wait for the go from the system to share my screen. Hi, everybody. Nice to see you. And I'll just be very brief in the introduction. This is, as Francesca said, part of a coordinated effort, and it's of a wider spectrum of activities that we're going through in those 2 favorite projects, Urban Pathways and Solutions Plus, where in this particular element we looked into the aspect of different aspects of battery reuse, repurposing and refurbishing and recycling aspects. And obviously this is coming at a time where e-mobility is finally getting to a size and share in the market where it really matters to think about this. When back in the days when only a few vehicles roamed around our streets, it would have been a different story. But now that the projections are very clear that on all types of vehicles, electrification is a key element that is happening, and they are getting considerable market share. It is vital to also look into the core element of the vehicle, literally and figuratively, the battery. This has started with a funded program, Urban Pathways, that is funded by the German government and the International Climate Initiative, and now is transitioning through the EU-funded program Solutions Plus, which is picking up where Urban Pathways has started with the conceptualization and now supports demonstration activities around the world in 10 living labs, bringing together a large pool of partners where we look into all sorts of e-mobility solutions. And in the context of this webinar, it is important to consider back why we should care about batteries. Of course, they are the heart of all the electric vehicles, and they take up the considerable size of the resources, as well as the financial elements, as well as the life that goes in the vehicle and beyond. So considering that there will be over 100 gigawatt hours worth of batteries that will be retiring within the next 10 years. This is a sizable amount of batteries that will look for another purpose in their life. And this is what some of those fact sheets that we're working on are exploring. Up until now, we have looked into more the reuse and repurposing of lead-acid batteries, but now obviously lithium-ion batteries are the way to go for now, at least with regard to battery technologies. So we'll need to get our head around unleashing this full potential of e-mobility, where it comes to sector coupling, energy storage, repurposing, refurbishing, recycling options. And of course, that starts with the battery design. And this is how the 4 fact sheets that the colleagues have developed so far are starting off with a fact sheet of battery design, where, of course, if we start right in designing the battery, then of course it is easier later on to repurpose, refurbish, and recycle them. And then it starts with 2 fact sheets on extending lifespan. So, of course, refurbishing means bringing them, breathing life back into them and bringing them to their original use case in the vehicle or in a vehicle. But then if that is not a viable option anymore, then we may very well want to look into what can you do with such a battery in a different sort of use case outside a vehicle. And then, of course, once those options are all depleted, then we need to look into recycling those batteries, and then there is a dedicated fact sheet on that, all of which will be introduced in this webinar and can be found on the solutions website. And maybe I'll just leave it at that and leave it to the actual experts from the team to tell you more about the fact sheets as well as what comes next. Thanks very much, Francesca, for the intro, and over to you again.
Thank you very much, Oliver. And I'm gonna share here in the chat for everyone the link to the fact sheets so that our attendees can go and check them out. Great. So I would like now to move on. I'm gonna take you very briefly through the agenda, and I'm going to briefly present the speakers before giving them the word to tell us more about these interesting topics. So we just had the first intervention from Oliver. Then we are gonna have Adriana Marchiori Silva. She's a research fellow at the UEMI. She's been working for 12 years in the environment and sustainability sector, in particular in the forestry and agriculture field. In just this year, she completed an Alexander von Humboldt Foundation International Climate Protection Fellowship, and has a research is focusing on circular economy, waste management, and sustainable city. Then we are going to have Emily Martin. She's also a research fellow at the UEMI. She has been working for 8 years in the field of public relations in the public transportation and railways in Brussels. And she now works in the implementation of electric mobility in cities under a sustainable and integrated perspective. And under UEMI, she's supporting a demonstration action in Kigali. Then we will have Juan Cariquiri, who is a professor and a researcher at the Faculty of Engineering of Uruguay, and is also a research fellow at the UEMI. At the university, Juan is also finishing his thesis on Master of Engineering of Energy. As we said, is also a professor and is specialized in electric vehicles at the Polytechnic University of Madrid. And at the university where he's currently teaching, is also setting up a laboratory for electric vehicle battery testing. And under UEMI is also working in the Solution Plus project, carrying out different activities for its implementation. Then we will have other speakers bringing some real case studies and experiences from the private sector. We will have Rasmus Bergström. Is the executive director at Stena Recycling Group and is also the managing director at Battery Loop. He started his career at Volvo Cars, where he worked for 11 years. And he ended as product planning director for Asia and Pacific. In 2001, he joined Stena Metal, where he became the business area president for all electronic recycling activities since 2013. And he's also responsible for the development of recycling lithium-ion batteries and managing director in this current position at Battery. Battery Loop develops and builds energy stores systems based on second-use batteries from the automotive industry and offers circular solution for recycling. Then we will have Virginia Taborda. Sorry, she's head of the business at Batteries, and she's also leading the Profit for Impact, a circular economy focused startup in business development, sales, marketing, and non-equity fundraising. She's been working for over 18 years in sales and business development of technical products and services across international markets. Before joining batteries, Virginia spent 4 years and working in social impact business, focusing on provision of renewable energy products and services in off-grid markets in Africa, India, and the Middle East. And last but not least, we have Marcello Fossati. Is a chemical engineer and is specialized in clean product in the University of Montevideo and in management of municipal solid waste in developing countries at the École Polytechnique Fédérale de Louisiane. And at the moment is a process chief at Werba, a company that has more than 80 years of experience in recycling processes. And beside leading projects at Werba that have focused on construction of a new line inside the recycling plant where electric vehicle lithium battery are recycled. So these are our speakers. I now give the word to Adriana that will take us through the first topic, the initial lithium, the initial design of the batteries. So now, Adriana, over to you.
Thank you, Francesca. Good morning, good evening. Thank you all for joining our webinar today. It's a pleasure to share my insights, our insights, and I hope we can learn from each other for the next 1 hour and a half. I guess now you should see my screen. So yeah, the first one of our fact sheet series, it's going to be about design and how it can catalyze a circular battery supply chain. I will give like a brief overview, and as Oliver mentioned, you can, and Francesca already put on the chat box, you can have access to the whole webinar, to the whole fact sheet content on the Solutions Plus website. So to give you a context of the impact, road transport are responsible for around 11% of global greenhouse gas emissions. So electrification is the key to decarbonize the sector. Once, of course, the EVs currently emit from 30 to 60% fewer emissions than combustion engines. So EVs also results not only for the GHG emissions, but in other positive externalities, such as improvement of local air quality, for instance, nitrogen oxide or particulate matter. So battery electric vehicles will probably account for most of the car fleet in the long term. And the lithium-ion battery market is the fastest growing market or segment. So between 2010 and 2018, battery demand grew around 30% annually. So the market is expected to keep growing at an estimate of 25% at an annual rate, as you can see on this graph here. So therefore, around 11 million tons of used EV lithium batteries are forecast to be discarded or disposed by 2030, represent a significant challenge, but on the other hand, also an opportunity, given the dramatic rise in demand for materials such as lithium and cobalt, right? So to move from a linear to a circular value chain can improve both environmental and the economic footprint of batteries. And let's not forget about also the social dimension. while we enhance collection rates and ensure alternative options like repurpose, refurbish, and recycle, that our next speakers will give more details about those flows, right? So implementing a circular economy approach means to have a comprehensive systemic vision to design the solution for your stakeholder or for the person that is interested in your service or in your product, right? And by stakeholders, we have to consider not only people, but at the first place, we have to consider the natural capital, which means that we have to consider all the ecosystem service that we depend on today. This is a very important topic that we would like to highlight here. And circular economy is, I don't know if you're familiar with the concept, but very briefly, it's a system that is restorative and regenerative by intention and by design. And it's based in three principles. So design out waste and pollution. So products are designed and optimized for a cycle and of disassembly and reuse in the same cycle. And the second principle is to keep products and materials in use. And the third one is to regenerate natural systems. So we can decrease resource dependence and increase systems resilience. What it makes circular supply chain sustainable, right? So on the circular supply chain, the social aspects, as I already mentioned, are crucial to guarantee the sustainability and a just transition to this new business model, to a circular business model. Therefore, the most relevant environmental and social aspects must be addressed on a circular solution. An important issue on battery supply chains are, like, for instance, that we would like to highlight here are for the raw material extraction. So two examples of negative impacts that we can talk in most of the countries that are responsible for these extractions, that over 60% of the global supply chain for cobalt, for instance, comes from the Democratic Republic of Congo. And from the 60%, 10% is estimated to originate from a small-scale farming, often in dangerous work conditions, and with some questionable labor standards. And the second example of a negative impact can be the mining waste disposal that we've seen, at least in my country, in Brazil, we had two major disasters related to it, and it's something that it needs to be addressed. So that scenario, allied with the resources scarcity, as already mentioned, it became clear that we need to design circular solutions to guarantee, but not only the sustainability of the existing stocks. And design goes beyond the traditional product and communication with the stakeholders. Currently, design plays the role of more social technical interventions, such as experience, services, and social innovations. And one key design approach that we deal in our fact sheet is the system thinking, which is in the category of a forecasting approach, which means that you think about the future from your experience on the present and in the past. So in this approach, you find the problem, you analyze the root cause in a systematic approach. That means the whole value chain and all the stakeholders involved in the process, and create a new system by decomposing and patterning changes, components, and all the synergies between the stages in the value chain and the stakeholders. So after you implement a pilot, you can evaluate how your solutions and your interventions affect the communities on a local scale. That's like a brief overview of this graph here that seems complicated, but in a nutshell, it's you have to listen to the community, to the stakeholder that is interested in the solution, and analyze all the synergies through the whole value chain. And that's the kind of approach that we need to achieve a circular battery supply chain, a participatory and user-centered and an inclusive approach. So design is at the heart of the circular economy. And it is through the whole value chain, we can, there is 4 stages that we can design for it, right? So the cycle of design is to understand, first of all, so get to know the user and or the system that you are designing it for. To define, so how to put into words the design challenge. To make, that's what we said, the pilot here is very important in this process, so how to design and prototype and pilot your solution. And finally, to release, that is launch your design and build your narrative on your solution. So on the fact sheet, you will find, describe these 4 stages specifically for the battery supply chain, and you can look in detail there. So I'm not giving you any spoiler here for that part of the fact sheet. Here, I just want to highlight that on the make stage, we explore different ways of being circular on the fact sheet. So when we design for reuse, maintenance, refurbishment, and remanufacturing and recycling, that all of the flows of a circular, of the technical cycle of a circular economy approach that we can call technically. So to produce these batteries with the responsibility and sustainability means that we have to lower emissions, ensure safe working conditions across the whole value chain, and improve repurposing and recycling. So a circular battery value chain that is a major drive to achieve the transformation of the economy in the value chain, and also in line with the Sustainable Development Goals that you can see here in the slides. So that brings me to the end of my presentation. I will hand over to my colleagues Emily and Juan to talk about the next steps for circularity in the battery supply chain. And I will be glad to answer any of questions that you might have. Thank you for your attention.
Thank you, Adriana. We will now have our Emily to tell us more about the repurposing and refurbishing.
Great, thank you. I guess you can see my screen right now, right?
Actually, not yet.
Okay, tell me when it's coming.
Yes.
Hello.
Hello, Juan.
Hello, everyone.
Emily.
Yes, Juan, can you see it?
No, I cannot. I can see the presentation.
Francesca, can you send in perhaps the link?
Yeah, let me try.
Okay,
Yes.
I think you should see it now, right?
Yeah,
Yes.
yeah.
Perfect.
Okay, great. So, yes. So great. So good afternoon, everyone. My name is Emilie Martin, and I work at UEMI. And I will, together with my colleague Juan, now dive deeper into the processes of repurposing and refurbishing electric vehicle batteries. So the idea of repurposing, which is also called the second life of the battery, is that the battery, once it has reached the end of its automotive use, so-called first life, then it has lost about 20 to 30% of its initial capacity, meaning there are still 70 to 80% of residual capacity that can be used for secondary applications as energy storage systems. So how does it work? The battery is removed from the vehicle, it is sorted, it is tested, and then reassembled as such or in a new battery pack. And I invite you to have a look at the fact sheet to learn a bit more about the different steps of the process. So what are these secondary applications as energy storage systems? They here I'm going to present a few of them. So first, supporting the electric grid management. It means, for instance, storing energy at times of low demand and releasing it at times of high demand. It's so-called peak shaving or peak leveling. A second aspect is to help integrating renewable energies into the electric grid. So for instance, wind or solar energy are by nature intermittent sources of power. So it's paramount, it's vital to be able to store them and to manage power generation and level them as well. So the third aspect is power backup. This is very important, especially in places with limited or unreliable electric grid. And finally, supporting decentralized energy solutions such as mini-grid or microgrids. It's still a nascent practice. We see initiatives and projects emerging over the last couple of years, but it is also a promising one. So for instance, the Global Battery Alliance estimates that in 2030, we can have 61% of EV batteries repurposed after the end of their first life. So this is a target scenario, but you can see the extent of promises. And it's linked to two types of gains. So first, environmental gains and then economic gains. So why environmental gains? So the first thing is that obviously it postpones the moment where the battery has to be recycled. It can go up to 10 years, and by then we'll have better technologies to recycle the batteries. Secondly, it can substitute to new energy storage systems, therefore saving on materials and resources. And if you consider that also linked with the fact that it helps integrating renewable energies into the grid, then altogether can contribute to reduce carbon emissions. The second gain that we can expect is the economic dimension. So by making use of the residual capacity of the battery, we can expect discounts on the upfront battery costs. That is at the moment a significant obstacle of electric mobility. We can reduce the cost of energy storage systems. We can create jobs at local as well as national, international level. So for instance, locally with the facility that are going to be created to sort and process, test the batteries. And finally, new business models. So as Francesca was saying, this type of new thinking is really about integrating different sectors, making stakeholders working together. Here you can see quite a lot of energy players, utilities, but also mobility actors, industry players, and so on. Coming maybe to the question of, okay, how do you do if you want to repurpose a battery? So and the types of challenges that you may face. Very frequently, there are three main types of challenges that are being faced. First, it's a question of the lack of data on the performance of the battery, what is called the state of health of the battery. And here, testing is very important. It's about the question, what is the lifespan that we can expect of the battery in its new application? Secondly, it's about anxieties and uncertainties regarding safety, especially removing, testing, disassembling the pack, and liability, because these batteries have not been designed to be used in this type of applications. And finally, economic feasibility, because repurposing involves transactional costs, also collection costs, and while at the same time we know we have decreasing prices of new lithium-ion batteries. So the good news is that we have a set of policy instruments and possible answers that we have collected in the fact sheets. So I really invite you to have a look at the fact sheets. And I cannot say everything right now, but just to give you a few hints. So for instance, the question of data exchange, very, very important. The idea of having a battery passport, the idea to promote business models where, for instance, the battery manufacturer will remain the owner of the battery in its automotive use, therefore monitoring the performance of the battery. That's something promising and also already applied. Safety and reliability, it has a lot to do with improving regulatory frameworks at different levels, international, regional, national, working on safety, on technical performance standards, transport rules, and so on. And for the liability aspect, involving the insurance sector. And finally, economic feasibility. Here again, we can identify some answers, such as having more demonstration and scale project, trying to identify best practices to streamline repurposing processes and bringing down the cost, but also further incentivizing the generation of renewable energies and maximizing collection rates. So that was a bit in a nutshell. I really encourage to have a look at the fact sheets, and now we'll be moving to the segment of repairing and refurbishing by my colleague Juan.
Okay, thanks, Emily. Thanks, Francesca, for your presentation. About repairing and refurbishing electric vehicle batteries, I would like to say that this is another opportunity for electric vehicle batteries. On the left hand, you can see the point of the battery life where repair and refurbish take place. In general, it can be at the end of the second life, but it also can occur during the use on electric vehicles, of course. If a failure occurs on a battery pack, repair and refurbishing takes place. On the right hand, you can see a general view and the structure of an electric vehicle battery pack with the housing shell, the upper housing, the lower housing, a lot of components inside the battery pack, cables, connectors, a cooling system, and of course, the core of the battery could be the modules and the cells, right? This is the general scheme of the battery pack. The next slide shows an scheme of the value chain for electric vehicle batteries. The first, at the beginning, well, we have the battery manufacturer. That battery pack is then installed inside the electric vehicle by the OEM. After that, it starts the utilization of the battery on the electric vehicle. And in one moment occurs the end of the first life of the battery pack. It depends on the aging of the battery. It depends on an early failure, and well, it could happen in different moments of the life of the battery pack. After that, when the end of life takes place, it is necessary to make a diagnosis of the battery pack in order to determine the cause and severity of the failure. Well, it can be using historic information and or opening the frame of the battery pack in order to see what was wrong in that battery. In this step it is defined the post-processing. It can be, as Emily said, repurposing. It can be the recycle of the battery pack, as we will see before, and it can be repairing or refurbishing the battery pack. If refurbishing is the solution for that battery pack, we will have 5 steps. More or less, it can be organized in this way. The first step is the screening or monitoring of the battery pack. It means that means the identification of the damaged cells. It can be performed by testing the cells and using the information provided by the battery management system. After that, the disassembly, it is the removal of some electrical and electronic components, battery modules and cells of the battery pack. Then it takes place the replacement of the factory cells plus verification and repeat of the entire electrical circuit plus the battery management system testing and reprogramming of the BMS. After that, of course, it is necessary, sorry, the previous one. After that, the reassembly of the battery pack, and finally, the additional testing in order to verify that the performance of the battery pack is correct. Now, yes. Oh, okay, thank you. Well, some levers for this activity. Of course, collection and picking of electric vehicle batteries, battery analytics technology built for diagnosis, specific diagnosis tools to determine the state of health and the chemistry of the battery. Design for disassembly, batteries easy to open, modules and cell easily exchangeable are a key. And a high degree of automation, and well, in general, an ecosystem with logistic operators and service stations are important levers for this activity. Well, to finish, the main gains for repairing and refurbishing are similar to repurposing. Of course, we would have environmental and economic gains. It would help to postpone the recycling phase. It would substitute new batteries. It will help to the GHG abatement, enlarge the battery life, of course. It could imply discounts on new battery packs. It can help to create new employment opportunities, new business models. And in general, refurbishing is a new and non-street activity with an important potential. The battery design for disassembly and lifetime extension is a key, is a priority. And well, it is not clear the benefit of this activity if battery aging becomes homogeneous. So more or less, these are the challenges and some questions and answers that we have regarding this activity. Thank you, Emily and Francesca.
Thank you very much. We can thank you, Emily and Juan. We now give the word to Rasmus, who will give us some, will share with us some experience from the private sector.
unmute, start video, and share.
Voila.
Voila. I hope that you can see my screen now.
Yes, we can.
Perfect. Then I will briefly introduce what we're doing. Not knowing all the participant on the webinar, Stena Recycling is a private-owned company, one of the biggest recyclers in Europe and especially in the Scandinavian markets. We are based head office in Sweden, so I'm a Swede and sitting right now in Gothenburg, Sweden, where autumn has arrived, which means it's raining from the side. We are focusing, we have a long background of recycling and recycling of cars. And that means, of course, with the big change of electromobility that we have heard numbers on this morning, or this afternoon, sorry, we see, of course, that batteries will come back. And as we heard from the previous speakers, that the life cycle of the batteries is possible for both reuse, remanufacturing, and then for second use. And our thought and flow of the material, I would say it's a bit of what you already seen. Of course, collection is a very important thing and a challenge, as these batteries will be all over the private owners as well commercial owners of batteries. Then we have what we call within number 2 there, diagnostic sorting pre-treatment, and this is actually what we just heard. We are then having our battery centers that we have around Europe, where we within our Stena Recycling company then are doing diagnostic of these battery packs. We sort them and we pre-treat them, which means what we just heard the previous speakers, the process, what to do. Here we are also, depending on the OEM, we are sending battery pack back to the OEMs for reuse, or we are dismantling, according to the previous speaker as well, then for remanufacturing of packs. But what I will mostly talk about then is the second use. Our belief then is very strongly that these packs can be reused. We heard as well previously that about 80%, 75 to 80% of the energy is still in those battery packs when the car is end of life. A commercial vehicle is end of life. The battery is end of life around 6 years after, 6 to 8 years after it's put in, for example, an electronic bus. The bus chassis lives, of course, much longer, but the battery needs to be swapped after 6 to 8 years, depending on where it's driving. If it's driving in a flat city like Hamburg, it's maybe 8 years. If it's driving in Peru with high heat and steep slopes, it's probably around 6 or even less. A private vehicle is actually today in Europe about 17 years old when it comes into recycling. But today no OEM actually so far in the European market has granted more than 10 years of guarantee of a battery. So we will see how that will end up. But we believe as well that has been presented that we will have a high number of second use batteries coming in. Today it's very limited, but it's still there. So we have started the company, which you see on the logotype, Battery Loop, which is a company belonging to the Stena Recycling, where we're focusing in building ESS system on second-use batteries, as well on new batteries, because there's so limited number of second-use batteries for time being. And then what we offer as well then, as we are a recycling company, we do the recycling after second use. And we believe right now with the installations we have done is that we can more or less double the life cycle of an EV battery in our second use applications, which is very, very good from a total environmental impact. And then, of course, we have the complete recycling activity and dismantling of battery packs to modules, and the recycling and extraction of the different material. So what are we then doing in battery loop? Well, this is what we call then a system overview. So a lot of activities on the European market right now is then solar production, solar cells. You see here is a case that we are building right now. And you can see here that solar production is a big thing as well in Sweden as in Europe. We know that based upon that, the usage of batteries will increase, because we know as well that vehicles needs to be charged, as well facilities like buildings you see up there needs to be supported, as the grid system that exists in many countries cannot take the amount of power that is needed. Because when all of us needs cars or all electricity in the buildings, the grid is an obstacle for actually receiving this. So what we're building is that the batteries, second use, we're building a battery management system, and of course then a data lake where we can really steer and monitor all the usage. So what we are saying is that battery loop is moving energy in time and room, because we could move it either to the grid, we can use it to charging vehicles, or we can lit up the facilities, and everything is either charged by the grid overnight or by sun over day. What we have done is we have, together with Volvo Bus, Volvo Bus head office is in the same town as we're sitting in. Volvo Bus is focusing a lot on electrified buses. We have done a global agreement with Volvo Bus regarding their batteries, and as I mentioned, we're maybe talking about 6 to 8 years until a bus battery is end of life. And what we're together with Volvo Bus developed then is a system like I just showed you on the previous slide. From a technical point of view, this is systems, they work. Most important thing right now for Volvo Bus as well for us is then the economic value of this type of system, and that will vary a lot depending on what country it is, because it's a regulatory business on power grid, for example. These systems, and here is a picture to the left, which is actually then what we have done. We have taken out the modules in the packs, and we build them in a rack. So that could be installed in a basement or in a house next door for supporting the facility. And the picture to the right, you see the managing director of Volvo Bus. Far right, me in the middle, and the real estate managing director for a real estate company in Gothenburg. So these are systems already in there. And of course, this is one type of ESS design that is possible. But what is also possible is actually bigger systems, where we're putting this in containers from actually 16 foot up to 40 foot, depending on the power needed for the support. And these are then supported by either charging from the grid or from solar cells, and we are having charging stations for cars. For example, one 16-foot container is today supported by solar panels. And then we have 80 charging stations for vehicles supported from driven by these batteries then in this. And this is then second use batteries we are working with. And after that, we're doing the recycling. So systems exist today, technology exists, and what is mostly lacking right now is second use batteries. So therefore, these systems today are both on new batteries and second use batteries. And that's a short introduction of what we're doing within Battery Loop and Stena Recycling for the continuation of the electrification of the automotive industry. Thank you.
Thank you very much, Rasmus. We now give the word to Eugenia.
Do I have to do something?
You can just turn off your video and mute yourself.
Oh, there we go. Thank you very much, everyone, for now.
Thank you.
Thank you, Francesca. Let me just share here. Yes, so we're similar to Battery Loop, but a little bit different in many ways, maybe not a little bit, more than a little. So we also upcycling, as we call it, electric vehicle batteries in their second life, but our focus is to put these batteries into use cases that are much more demanding, really that require mobile or portable energy, as well as on many levels multi-purpose applications, as well as modular uses of energy. And again, one of the key things for us, as I think Emily pointed out, is that we can offer solutions in these areas in an affordable way, and doing that by using by upcycling second life batteries. And that's really where we started with, you know, these two challenge wave of batteries coming out of electric vehicles, and a need to really do something to replace mainly generators, to really offset the greenhouse gas emissions, but also to offer a more affordable solution, because we know that that is one of the big problems impeding adoption of renewable energy is affordability. So that's what we have set out to do with our solution. Again, kind of goes back to what some of the other panelists were looking at, is really building on this idea that there's a lot of capacity still left in the modules when they come out of EVs. As Battery Loop and a few others alluded to, you could almost double the life of the battery by repurposing it in a second application. And we know today, and hopefully this stays for the foreseeable future, of course, second life batteries are about half the cost of first life. So this can give you huge potential benefit on the economic side. What we do is we, similar to Battery Loop, actually unpacked the EV packs that we receive, and then repurpose these into smaller batteries around 2.2 to 3 kilowatt hours each. And this, again, requires testing and other things, but we also use quite advanced battery management systems to really get the most life out of the cells in the modules that we're reusing. Full system approach, in that we have not only the battery, as you can see here, but also the full system that allows you to basically charge the battery with any energy source and then discharge both AC and DC. So we think ourselves really as an integrated solutions provider, because we're not only using the second life modules to build new batteries, but we have the full system that allows you to charge and use the battery. Part of our design, as I mentioned, is to allow portability and mobility. The batteries are around 30 to 35 kilos each, which is a bit hard one person to carry, but again, our design where you can dock battery into this cart and then of course charge it or take the energy out allows it to really be portable across dirt roads, in the rain. It's really the idea is to have something that is extremely robust, waterproof, so that it really can be fully multi-purpose. As I also mentioned, it's modular, so you can stack up to 4 of the batteries on this single universal module, as we call it. Inside here, you have your bidirectional inverter, which allows you to charge really from any energy source and discharge in either AC or DC. We also have a platform, a data platform that of course is allowing you to monitor the batteries as in service, and as well as to enable predictive maintenance, remote control of the battery to turn it off, which allows you to very easily enable a rental model around this and an individual ownership or rental model. As I mentioned before, our solution is a full system approach. And this allows us really be multiple use cases, as I mentioned. One of the key aspects in the design is that it can be used in many different ways, and really identified kind of three major markets around this. With our bidirectional inverter system, you could use this for an on-grid backup use case. So where the batteries are charged by the grid, and then when the grid fails, obviously the batteries could charge essential loads. So this would be critical in areas where the grid is weak or where you have some kind of disaster or emergency. We also have the ability to, of course, take the battery off the stack and use it with what we call this connect module, which enables you to draw DC power to power many things on the productive use side, and really allowing this full portability where the battery and the cap itself could be used in the field. And thirdly, which is the most interesting, of course, in this context, in this webinar conversation, is that our batteries can power e-mobility. So here we have a very simple docking module that can enable our batteries to be used in 3-wheeled vehicles as well as in boating. So we're really going from the EV back to the EV to enable e-mobility, of course, at a much lower price point. Of other really suggest opportunity for the use of our batteries. I think in the design, there's a critical aspect of understanding, what is the right size for production. There's a big gap, I think, now between solar home systems and then, of course, larger production in mini grids. And how can we help, fill that gap and really enable much greater use of productive use on renewable energy. So as I mentioned, of course, we look at the backup power situation, electric propulsion, actually helping to allow mini grid developers to distribute their energy outside of the grid lines, and of course, distribute a greater amount of power without any disruption to the grid. As I mentioned, I think our solution is perfect for humanitarian aid and in cases with natural and man-made disasters. E-transport is a big one that we're focusing on in Africa at the moment. And then, of course, you could use this for EV charging of smaller EVs, like motorbikes and other things very prevalent in India. This, again, could be a way to distribute energy even from the grid to charging points to enable the greater adoption of electric mobility in smaller motorbikes. So I think, again, to really highlight what we were working on in this market in terms of electric three-wheelers, It's something where this is a very nice use case, considering not all three-wheelers, but most three-wheelers, their normal range, as well as the weight that they need to carry. So we can use one or two of our batteries inside of the three-wheeler to power the three-wheeler, allow it extra range, but also to power productive use equipment when it arrives at its destination. Wanted to transport, say, produce from a farm to a market, but maybe you also need cold storage along the way. It could power a small cooler, or again, power some kind of pump or other thing when it arrived back in the farm. So it really allows you a lot greater flexibility than what you could currently achieve today with ICE powered or even other electric power three-wheelers. We're working on this particular topic with a couple of different partners in Africa, Mobility for Africa, who's been piloting in Zimbabwe, and Alico and Micro Energy International on potential projects for the Tanzanian market. But really, it comes back to the focus that we have at batteries, which is really having a positive impact on the environment. So to stop or to prevent some of the future impact. So our goal is to save over 1 million tons of CO2 by 2030, and we have quite detailed analysis impact metrics against the use of our solutions versus generators and ICE powered three-wheelers. Plus, of course, the savings you can have by reusing a battery rather than using or producing a new battery. I thought I would end with just a quick video that we recently produced to show really the multi-purpose nature of our battery packs. Let me just bring this here.
Is there any audio in the video, Virginia?
Is it not playing for you?
No.
Oh well. We'll just have to have the. It's almost over.
Okay.
If you want to see it again, with the audio, then please go to our website and check it out. We've put it there as well as on our LinkedIn platform. It's a very nice music. I'm sorry it didn't work as well as I planned.
It's fine, but thank you very much for your presentation, and we are running a bit late, so I would like now to give the word to Marcelo, and then we will finish with Juan. So Marcelo, now you will be able to share your screen, and you can take us through your presentation. Thank you.
Okay, thank you, Francesca. Hello, I'm Marcelo Fossati. I'm a chemical engineer at Verba Sociedad Anónima. We are a Uruguay's leader in non-ferrous metals and weir recycling. And we've been working on a project to install a lithium-ion batteries recycling plant here in Uruguay. Just to have a little bit of background of Uruguay, we're a very small country with very little population. We have signed the Basel Convention that has inspired us to set a facility here in Uruguay so we can recycle our own disposed batteries. We used to export lithium-ion batteries to be recycled abroad, but since the Galaxy Note 7 incident, all shipping companies that come to Uruguay have denied shipping them abroad, mainly because of the fire and explosion risk, even though we have the permits and the safe packaging. So Uruguay's current solution for spent batteries is send them to a secure landfill for hazardous waste, which is obviously not the best solution. And we still don't have a specific legislation on lithium-ion batteries. So we had to think of a project that would avoid sending the batteries to landfill disposal, to eliminate the explosion and fire risk, to have independency from the shipping companies. We wanted the process to be able to recycle multiple formats and chemistry batteries. We want a high recovery rate and obviously to be economically viable. So there are mainly 3 different processes and treatments for the recycling of the batteries. The first one would be the mechanical treatment, where it's basically the shredding, crushing, sorting, and classification of the battery cells. We can retrieve from that process the copper, aluminum, metallic nickel, steel, plastic, the electrolyte, and the black powder. Then we have the pyrometallurgy process, which consists on high temperature smelting, where we can basically recover the base metals like nickel, cobalt, and copper. However, in this particular method, some of the metals cannot be recovered, like aluminum and sometimes lithium. And the last one is the hydrometallurgy process, that it involves the use of aqueous solution for the recovery of metals from the recycled materials. In this case, it would be the black mass. So we can get the nickel, the cobalt, copper, manganese, lithium, iron, graphite from the black powder. We base our process on the LithoRec project, that it was that were projects funded by the Germany Federal Ministry of the Environment, Natural Conservation, Building and Nuclear Safety, that aim to develop a new recycling process for lithium-ion batteries from electric and hybrid electric vehicles, with a focus on the energy efficiency and a high material recycling rate. The process consists mainly on 2 stages. The first stage would be a mechanical treatment that we would carry on here in Uruguay, and a secondary stage that will be carried on abroad, that is the metallurgy process. So we have the battery packs. The battery packs, as other speakers just told us, we have the battery modules and the battery cells. What we want to recover is the components of the battery cells in the mechanical process. We want to recover the anode. It's a copper foil with a graphite coating. The cathode, that is an aluminum foil with the active material coating. There we have the cobalt, nickel, manganese, and other metals. Both of those, cathode and anode, are separated with plastic foil, and of course we have the electrolyte. So we need to start our process. The first step would be the sorting of the batteries. We will sort them, we will test them and see if they are good to have a secondary life, or if they are damaged, that we need to send them to recycling. And the first step of the recycling would be the discharge of the battery. We can use that energy to power up our process, or we can send it to the power grid. Once that the battery is discharged, it is safe for the disassembly of the batteries. we expect to disassemble the battery pack and the modules so we can recover the metal or plastic casing, the cooling unit, wires, bus bars, screws, the battery management unit, and all of those would be sent for conventional recycling. The battery cells would go to the next step, that it would be the shredding of the battery cells. We must do it in an inert atmosphere due to the flammable electrolyte solvents. The shredded material will pass through a rotary kiln that it would be heated between 80 and 140 Celsius degrees and decreased pressure so that the electrolyte will be vaporized and then condensed to be recovered for using in the fabrication of new batteries. The rest of the shredded material will be sent to a magnetic separator where we will get the magnetic material, steel and metallic nickel from the rest of the shredded material that will then pass through a secondary shredding process, which idea is to get a size homogenization and to release of the coating from the anode and the cathode. Once that the material has been shredded, it will pass through an air classification system, a zigzag sifter, where we will get two different fractions. We'll get the light fraction that consists of the plastic foil and the black mass, and the heavy fraction that is mainly aluminum foil and copper foil. The light fraction will be sorted in a vibrating sieve. We will get on one hand the plastic foil and on the other hand the black mass that then will go to the hydrometallurgy process, and the heavy fraction will be sent to be sorted on an optical sorter or a density separator. And as I was telling you, the hydrometallurgy process, we will send the black mass or black powder abroad, since the volumes of materials that we can get here in Uruguay are very little. We will send them abroad to be recycled, where they will do the leaching, the concentration and precipitation, and the recovery of the metals. Here are just some of the companies that do that process. We can add also Accuser. And our final conclusions is that we expect to eliminate the explosion of fire risk during transportation and storage, to have a high recovery rate, that of course that it must be economically viable, and also this process can be replicable in other countries. On the other hand, we will still depend on hydrometallurgical plants abroad. And that's basically all. Thank you very much.
Thank you very much, Marcelo. So we don't have much time. I would ask the attendees if they have any questions. They can post it in the Q&A box. Meanwhile, I would just ask all our three speakers, Marcelo, Rasmus, and Virginia, if they can give us very briefly the main challenges that they are encountering, and also which are the main policy requests. So just like bullet answers, just for the interest of time. Maybe we can start from Marcelo, since he was already on. Yeah.
Thank you. Yes, here in Uruguay, we are, of course, some steps back from European or American recycling processes. It's something that's just starting. We have, as it was showed in the presentation, we still don't have a legislation for the recycling of lithium-ion batteries. and we are just starting with our project. So it's basically all new for us, and it was really great to hear, for example, from Rasmus, the experience they can share. So that's basically all. Thank you.
Thank you, Marcelo. Rasmus or Virginia, you want to go? Maybe we can have Rasmus since he's on already.
Okay, Rasmus here. Thank you very much. Thank you, everyone. I think we all are in challenging opportunities. I think what we see as challenges, if we take the whole value chain, is collection of material, hard of EVs as the ownership of this will be the last owner. This will be a challenge, I think, for all of us. I think the development of energy storage system, the technology is there. The value for having ESS systems are there with second use. I think what is the most important thing is to learn the different local regulations, taxations on how profitable could ESS systems be in the different countries or even different cities, because it varies from city to city, even in a country. I think that's a challenge for us. The recycling activities for us is like we heard in the last presentation. I think from a technical point of view, the recycling activities are also there. From a functional point of view, sorry. So I think the biggest challenge we have as society is how do we get hold of all the second-use batteries in a good way. Two, we need to have ESS systems locally in the different cities and countries, which means we will require a lot of information on how to do this and how we could define the financial things. And three, the recycling activities will be there. I'm not worried about that. Thank you.
Thank you, Rasmus. Virginia, would you like to give us your answers?
Yes, I mean, one of the biggest challenges we face to do of second life batteries and non-classified so you can import them, export them more freely between different countries. Of course, we know there's a lot of limitations on the transport of lithium-ion batteries in general, but I think, again, this policy towards, how to classify second life batteries in new applications would be really helpful. And then I think, again, recycling, as many of the other panelists are working hard on this, it's still not where it could be. And I think for all of us, the goal is to reuse and then recycle in the right way. So how can there be more research and development funded by various governments towards this, making the process actually a value creation rather than just a cost to the actors in it. So I think those are two key elements that we see as potential obstacles that, of course, could be helped by policy.
Thank you, Virginia, and thank you, everyone. We are just perfectly on time to finish our webinar. So I would like to thank all the speakers for sharing their experience and giving us insightful ideas and also case studies. I would like also to thank all the attendees that have joined us today. And I'm gonna write in the chat here the email addresses of our colleagues from the Urban Electric Mobility Initiative. So in case if you have any questions addressed to UEMI or to UNHabitat or to one of our speakers, you can just write to them and then we will answer them. So thank you very much, everyone, and Have a great continuation of the day. Bye-bye.
Thank you so much.
Thank you, Francesca. Everyone.
Bye bye. Thank
Everyone.
you.
Bye-bye.
Bye.